So we've got triangle ABC, and we've got triangle A prime, B prime, C prime. We want to know, is there some kind of rigid motion that maps one to the other? Y'all guys got to look a little more alive. Y'all are depressing me the way you're sitting around. Like you're taking notes and you're really,
What do you think I'm
involved. I'm just telling you, I feel real depressed. Like there's no point in me even teaching right now. Okay, so if I look at ABC and I look at A prime, B prime, C prime, do you guys think rigid motion has occurred?
No.
Why not? Okay, what does it mean to have rigid motion?
It's where it moves and it stays the same.
Right, the distances are the same, the angles are the same.
And it has rigid motion.
So let's see, how far is it from A to C?
2.
2. How far is it here from A prime to C prime?
2.
2. How far is it from B prime to C prime?
3.
3. From B to C is 3. So we can't count this one, but it looks like it's still the same length. So we can say rigid motion has occurred because it's kept the same shape, it's just in a different location. So we have had rigid motion. Now, next, how can we get from the original ABC to the image A prime, B prime, and C prime? What kind of transformations would we have to do?
You could flip or rotate it to the positive side and then translate down.
So we could rotate it. How much do you want to rotate it? How many degrees? 360? So if I rotated 360 degrees, what would happen?
You go right to the same spot.
You'd just be banging the same spot. So
Kinda like
there's,
where A would be, so where instead of A being -5, how about like where it would be on this side closer to you? The way that B prime and A prime would look up. Because I'm trying to use that line thing, flip it over.
reflection.
Reflection, yeah, that's what I was
So you're trying to reflect it.
Reflect.
So not rotate it.
Not rotate,
Reflect
then
it.
drop it. Then drop it.
Okay, what do you guys think? Would a reflection help here?
If you reflect it over -1, it'd help.
Reflect it over -1?
Yes.
How did you get -1?
Because they're 4 dots apart.
I say we just let Grayson teach.
I just looked at.
Okay, so from C to the line would be 2, and then from the line to C prime would be 2. From B to the line is 2, B prime to the line is 2. From A to the line would be 1, 2, 3, 4. From A prime to the line would be 4. So yes, we could definitely reflect it over this line, x equals 1, or -1. So I have a reflection over the line, x equals -1. Now when I do that, let's see, what's going to be my new coordinates? Well, we count over, right? 1, 2, 1, 2, that means right here is B prime. Same thing here, if I count over with C, 1, 2, 1, 2, this is C prime. And then 1, 2, 3, 4. 1, 2, 3, 4. That means right here would be A prime. So once I do the reflection over the line Grayson told me to, that puts me here. Have I finished? Am I exactly on top of it now? No, but am I closer?
Yes.
Yeah, it looks like it's facing the correct way now. So the reflection helped put it where it's supposed to be. Now what do I need to do next? I need to
Translate it down.
translate it down. How'd you get 5?
I counted.
Counted which point?
From C to C.
So from C prime here to my final C prime, this will be 1, 2, 3, 4, 5. So we need to move down 5. And that works for all of them, right? 1, 2, 3, 4, 5. So then after I reflect it, I'm going to put a circle. Then I need to translate it. How do I say I want to go down 5? Remember, translations have these parentheses.
0, -5.
Very good. 0 tells me I'm going left or right, nowhere. -5 means I'm going down 5. So right here would be my combination of rigid motion, of transformations that gives me my final graph. Is this the only way you could do it?
No.
There are other answers. Okay? This is one. Let me show you another one you could do.
You could translate, then reflect.
You could translate, then reflect. Absolutely. Or what if I reflected somewhere else? Like what if I reflected over the y-axis? So if I went reflection over the y-axis, okay, then what would happen? 1, 2, 3, 1, 2, 3. That means that gives me B prime here. 1, 2, 3, 1, 2, 3. C prime would be here. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That gives me A prime here. Now if I did that first, then what would I need to do? I would still need to do a translation, but now how much am I going to have to move? Now I'm going to have to move left 2, down 5. So there's more than one correct way to do all these, right? You could reflect it over an even a different line. Or like Grayson said, we could have slid it first. You could have shifted it down and then reflected it. And then if you reflected it and it didn't end up where you wanted to, then you could have shifted it again. Right? I mean, you got all kinds of options. We just want a list of transformations that puts me mapped to the image. Okay, so I'm going to graph this. So it tells me R is at -3, 2. So I'm going to go left 3, up 2. I'm going to put in R there with it. S is at 0, 5. Huh? That's S. Are you talking to me?
Oh, no, I just.
Okay.
I was like graphing while you graphing.
Gotcha. T is at 4, -4. I'm going to 4, down to -4. Right here is T. Okay? So if I'm going to V, I'm going nowhere except down 2, which will be right here. And this is my point V. Now I'm going to connect these 4 points to make a quadrilateral. That is ugly.
Okay, we won't tell you. It's a diamond in the rough, you know. We don't know what it is, but you can get it.
I know what it is. It's a quadrilateral. It's a 4-sided figure.
That's what I'm saying. Diamond in the rough.
Okay, so what's the next thing I need to do? I need to translate right 1. And then go nowhere. So I'm going to move all of these right 1. So that means this point becomes R prime. This point becomes S prime. This point becomes V prime. And this point becomes T prime. Here, I connect these. So I can see what a quadrilateral looks like when it has been shifted right 1 unit. Okay, then next it tells me to reflect it over the x-axis. So that means I'm counting how far away from the x-axis am I, and then I'm going to reflect it. So when I look here at R is 1, 2 away. So I'm going to go another 2 away. So that means right here is going to be my point for R double prime. S, I'm going down 1, 2, 3, 4, 5. So go down another 5. 1, 2, 3, 4, 5. And so right here is my point S prime. T, I'm going to have to go up. 1, 2, 3, 4. So go up another. 1, 2, 3, 4. And so right here is T prime. And then V is here. I have to go up 1, 2. So go up another 1, 2. And so right here is my point V prime. Then when I connect them, I have my quadrilateral after it has been reflected. So you see, I'm just combining my two rules that they give me to create the transformation they are looking for. Okay, so I'm going to go ahead and make sure we got the graph going here. It tells me A is at negative 3, 4. Right here is A. It tells me B is at negative 4, 2. So here is B. And C is at negative 1, 1. So here is C. Okay, then it tells me A prime is at 1, 1. So right here is A prime. B prime is at 2, negative 1. So I need to move where I got this written. Put it here. B prime is at 2, negative 1. And C prime is at negative 1, 2. Negative 1, negative 2. Okay. So first thing, let's look what I need to reflect over. Well, let's see what's in the middle of A prime and A. Well, let's figure out. Look, because A and A prime stayed up here, where did I reflect it over? It would be a line like this, right? You see how B and C have changed their position? Well, look, because C and C prime are in perfect line here, then that's probably the line we're reflecting over. So I'm thinking I'm probably going to reflect over this line here. Because look, from B to that line is 1, 2, 3. B prime to that line is 1, 2, 3. So that lets me know that that's where I need to reflect over. It's in the middle. A, 1, 2, A prime, 1, 2. So what's the equation of this line? That's the line x equals negative 1. So I'm going to reflect over the line x equals negative 1. And then how much do I need to move down? 1, 2, 3. All right, 1, 2, 3. 1, 2, 3. So then I need to move down 3. So it'd be a reflection. X equals negative 1, and then a translation down 3. So it'd be 0, negative 3. Now the second one, this time it's just a line segment. So it tells me R is at negative 2, 4. It tells me S is at 2, 6. So this is R, this is S. And here I'm connecting them. And then it tells me R prime is at 4, 0. S prime is at 8, -2.
I think we did the R prime and S prime backwards. So they're supposed to be opposite.
Yep, they sure are, ain't they?
Their X is up
That's a good call. I was just testing you, see if you're paying attention. R prime is at 4, 0. And then S prime is at 8, -2. So let's see, how is it reflected? Well, because R is still on the left side, I know I don't need to reflect it across a vertical line. 'Cause if I reflect it across a vertical line, then that will move R farther away. So I'm going to have to reflect it over a horizontal line this way. So I'm finding the middle of R and R prime. So that would be at 2. Right, so I'm going to reflect it over the line y equals 2. And then once I do that, it's going to put me here. And 1, 2, 3, 4. 1, 2, 3, 4. And here. So this would be my new one. And then how much do I need to slide over? I need to go over 1, 2, 3, 4. I got 5. So this used to be at -2. Oh, I counted wrong. I counted wrong. That's my fault. I drew my line. Hold on, I drew my line terribly. So that's at -2, 4. Which means that this needs to be here. Like that. That looks better. And so then if I reflect that, 1, 2, 1, 2, that would go here. And S is at 2, 6. So that would go to, that's wrong. 1, 2, 3, 4, 1, 2, 3. Go to here. So I need to move it 1, 2, 3, 4, 5, 6.